Hi guys, this is Srimati. I'm going to take industrial controllers for this semester, and my specialization is power electronics and drives. I'm working with VIT Chennai in the School of Electrical Engineering. My research area includes embedded systems, microcontroller based systems, microprocessor based systems, IoT based systems, and the mathematical modeling of converters, DC-DC converters, and energy conservation systems. Coming to industrial controllers, and what are all the controllers that is being used in industries, okay, that we are going to see in this subject. So coming to module number 1, it is about the programmable controllers, an introduction to programmable controllers. What are all the controllers that is available in the industry for the automation, and general description about your mini-computers, digital signal processors, microprocessors, microcontrollers, programmable logic controller, and soft PLCs. And in this unit, the SLO that is being covered as SLO is nothing but student learning outcome. Having sense making skills of creating unique insights in what is being seen or observed. So, what is there in the industry? What are all the controllers that we are using? And for what purpose it is being used? That is the SLO we are going to cover here. So, before going into detail about the types of controllers available in the industry, let us go ahead with industrial automation. What is it to be industrial automation? For example, in an automobile industry, for making an industry, for making a two-wheeler in an automobile industry, let us take a two-wheeler manufacturing industry. So for that, what are all the components we need? We need an engine, the basic components I'm telling about. We need an engine, we need a brake system, we need seats, and we need wheels, right? So these are all the main things that we need. So each and you have in an industry, you have many plants. Each plant will do an operation. For example, your seat, your handle can be made in one plant. And after that, you have a tires, two tires that can be made in another plants. And engine-based systems that can be made, and related brakes, everything that can be made in some other systems. The headlight, the front headlight, the back headlight, that can be made in the other plants, and assembling can be in one of the plants. So these are the process in the industry. So for process in the sense, like as I said, the wheels, the seat, the front and back lights, so these are all the process involved. So for each and every work that we are going to do, we need an industry, we need a machine. So each and every machine will perform an operation. For example, if it is making a wheel, or if it assembles a wheel in the two-wheeler, so we need to give the input. So what is the input? What is the wheel you have to take, or what is the wheel you need to fix, either the front wheel or the back wheel? If it is the back wheel, what is the size of the bolt or the screw that has to be used? And what is the headlight that is we are going to use? Like that, we need to feed the input data for the particular machine, only then it will do the operation. And then we need to check the output in the sense, after assembling, after fixing up the front wheel, we need to check whether it is properly assembled or not as per our instructions. This and all will be programmed inside the machine. If it's a big machine, okay, it will be programmed. So controlling this operation, so we are going to give the input, and the machine will be doing the output, and we are expecting our desired output from the machine. So that involves control system, right? So I need this sort of output. So perform the operation accordingly. That is said to be control systems. And for feeding the program inside the machine, I need computers and robots. For example, now we are, instead of human being, we are using robots also for performing operations. And from the plant, I should see from each machine will be operated by a machine level operator, and you have a supervisor for seeing all this operation of the machines. For that, you have a supervisor, and the particular plant supervisor will communicate with the plant manager, and the plant manager again he has to report to the central system, right? So for each plant will have a plant manager, and under him you have a supervisor, and we have a low level workers also. So all the machines used by the low level workers will be supervised by the supervisor, and the information has to be passed to the central manager or the production level head. That will be done by using your information technologies. Okay, information technology. So this is said to be industrial automation. Automation. Okay, automation. This is the second level beyond your mechanization. Okay, so industrial automation systems, you what does mean by industrial automation systems? Industrial automation system is nothing but it is a system used to monitor a process or an operation of a machine or a device in a computerized manner. Okay, that is said to be industrial automation systems. Okay, so it will be doing repetitive task according to our requirements, according to a your or our requirements. That is said to be industrial automation systems. And let us see what are all the industrial automation systems that are available in the industry. Before that, for doing this automation, we need certain control systems in the industry. That is said to be industrial control systems, otherwise ICS. Okay, it is a collective term that is used to describe different types of control systems and the related instrumentation. Related instrumentation in the sense, as I said, if it's a PLC based machine, PLC based machine. What is a PLC based machine? PLC based machine, programmable logic controller. It is this programmable logic controller is for a particular machine, only one machine. One machine you need to feed the data. For example, if it is a food based industry, if I need to segregate the food grains into 5 different categories, my input will be the food grain. My output will be 5 categorized grains into different qualities. Okay, for this I need to give input to the machine, that particular machine. This is the input. Measure the size of each and every grain. Categorize this into 5 different quality. Okay, that is how I need to program the machine. Okay, for this I need the input. Okay, I need to see what is happening inside the machine. You have an input device, you need an output device to monitor the output into 5 different category, and we need to program the machine in such a way, do this segregation here inside the machine. That and all can be done by using your PLC. PLC is for a particular machine. Okay, so for that we need certain instrumentation, because we need to monitor this unit computer, and the basic operation has to be sent to the supervisor. For that I need communication technologies. So this everything comes into picture. Okay, that is said to be ICS. That is said to be ICS. So what are the ICS technology that is being followed in industry? This we will see in detail in the upcoming slides, and these are the types that is involved in ICS technologies: SCADA, DCS, IACS, okay, PLCs, okay, and the PAC, Programmable Logic Controllers, okay, PACs, HMI, RTU, control servers, IEDs, and sensors. And what is meant by SCADA? Supervisory Control and Data Acquisition System. So it is a computerized based system. Okay, SCADA. This particular computerized based system is used in the power industry, power sector. For example, you will be generating power, you will be transmitting and distributing power. So you will be having several substations, and you will have several distributing stations, and power generating stations. All these operations should be monitored and controlled sequentially, and in every region. You have a zone. In that zone, you have many regions, and you need to monitor those regions, and you need to distribute the power properly. Okay. So you have many things involved in that. You have a relay, you have a generator, transformer, machines involved for generation. So you have many challenges there. So that can be easily communicated by different regions from the zone by communication technologies, either by phone lines, microwave, and satellites. And this is being involved, covering long distances because. For example, in Tamil Nadu, you need to cover the entire region, or in Chennai, if I need to distribute for the entire Chennai, I have different regions involved in it. I need to know what is happening in the distribution sector in each and every region. So we need to collect those informations and data, and I need to apply the controls and that particular region when and where required. Okay, that can be done by using the SCADA supervisory control data acquisition system. And coming to your PLC, PLC is said to be, as I already explained about PLC. PLC is nothing but a solid state device. What is a solid state device? It is a device made up of germanium or silicon. It is a device made up of germanium or silicon. It is a device made up of germanium and silicon. You will be using those. You will be using those. Devices for doing the operation in a machine, for doing the operation in a machine. So solid state control system is that where it is a device made of germanium and silicon semiconductors, etc. You have many more. I'm telling about germanium and silicon. You have arsenic, you have many semiconductor devices available. So those semiconductor devices will be used here because basically ROM and RAM, generally the user programmable memory, is used. It is done by your. You will be using flip flops in that. So flip flop, you would have heard about flip flop. It's a single bit storage unit. So when I need to store 8 bits, I'll be using 8 different flip flops involved in it. So each and every line of memory in a RAM will be having 8 bits that can be stored here. 8 bits can be stored in each and every line of your memory. So here PLC is nothing but you have a central processing unit, and then you have an input device, and you have an output device. Okay, and this put together, it is there inside your machine. So this CPU, again you have your ROM, RAM, everything. And obviously, if you have a CPU, you have a timing control unit. And as I said, if I need to control the output of the machine, that can be the control system used here is PID based control. And this information has to be passed to the higher ups by means of communication based on the application that we are using the machine. Either we can do arithmetic process, or I may process the data. That is about your PLC, programmable logic controller. That is for a particular machine, one machine. Okay. Coming to the distributed control system. So distributed control system, as I said earlier, you have different plans inside the industry, and each and every plant you have several sub levels from the manager top level till your lower level worker. You have several categories that is being involved, and we need to monitor each and every plant individually. For that, we have a certain instrumentation based systems, like we have a sensor, and we have Wi-Fi. Now and all you have Wi-Fi based system, and where you will be communicating that the process involved in the particular plant to the higher ups, right? So here you have data acquisition. That data, whatever data that is being acquired, we need to store, and we need to check, and we need to process the data, and we have to give appropriate command to the individual plants according to the data that is being collected. Okay, so for this as entire control system that is being involved, we have we have a sensor, we have a controller, and an associated computer that is distributed throughout the plant, because all the computers will be connected in each and every stage. Will be having a computer from the machine level to the supervisor level, and to the manager level, and to the plant level, and to the industrial level. So everywhere your computer is being connected, all the computers will be connected through a LAN network, okay, through a local area network. Okay, so this is how your diagram will be. The distributed control system, you will be having a computer, you have a plant here, you have individual machines. Let me assume that you have a microcontroller based machine, and each and every machine will be controlled by will be supervised by the supervisor, and then the supervisor will report to the coordinator, and the coordinator will report to the center. Okay, so from field level, direct control, plant supervisory level, and production level, and the production scheduling. This is how your control system will be. Distributed control system will be. Distributed control system is distributed throughout your plant or throughout your industry, whereas PLC is nothing for a single machine. So that is the difference between PLC versus DCS. PLC is used to control individual machine, whereas DCS is used to control the entire plant, number of machines. Okay. So coming to your remote terminal unit, that is said to be RTU, it is again a microprocessor based electronic device used in industrial automation system to connect different hardware to the distributed control system. Okay, so distributed control system in the sense you will be having many more categories in the distributed control systems, namely your from the field level to the head level you will be having many more categories. And this for example, for plant number 1 you have plant 1 and you have plant 2. Okay, so connecting this plant 1 and plant 2 can be done by a hardware. Okay, connect this plant 1 and plant 2. It will be a microprocessor based electronic device that will be connected to the plants. So that, and through microprocessor based unit you will be connecting it to the remote terminal unit. It's a microprocessor based electronic device used in industrial automation system to connect different hardwares. Hardware in the sense, again, plant 1 is having many number of hardwares, many number of machine levels. Okay, those hardwares will be connected to the remote terminal unit with the help of your microprocessor based electronic device. And this units can be a telemetry type of device, or it can be a remote, you can control this remotely. And again, your RTU, the remote terminal unit, has the sensor data. Okay, so whatever that is being sensed, and that will be passed to the central room, control room, or the server room, and where the commands, which in turn will pass the commands to the RTU, and again RTU will feed to the plant. It is basically it's a sort of IoT based system. Okay, and coming to the industrial automation and control system, it involves both hardware and the software and communication alternatives to transform the sensed information into another information. Okay, so sensors and machines in each and every machine inside the plant can be done. Okay, this entire thing whichever I said, this is being passed here as comments from the RTU, will be passed here to the plant 1 and plant 2. This entire thing is said to be your industrial automation and control system, because we are in turn based on the data that we have received from the plant, there is showing certain comments to control the process that is being involved in the plant. So next is your programmable automation controller. So, and see, so basically the programmable logic controller, it may be used with the microprocessor, microcontroller based systems, embedded systems. What is embedded systems? It is designed for doing a particular operation, and washing machine in our home is an embedded system. It is used for performing only washing operation. Like that, we have many much more embedded systems involved with microprocessor and microcontroller based systems, and that and all will be using the assembly language program, and nowadays we are using the PLC also, and the C level programs also done. And if I'm programming a controller with higher level instructions, Okay, that will be used in critical infrastructures like in noise and infrastructures, in hospital equipments, and in vibration based infrastructures. Those infrastructures we cannot access in, so those areas, this type of programmable automation controllers will be used, and this is also a rugged system, and which can withstand the industrial environment. Okay, there your programmable automation controllers will be used in the critical infrastructures. And coming to the electronic devices, intelligent electronic devices, an intelligent electronic device is an electronic component that has a microprocessor, and it can communicate typically by using your field bus, Ethernet, and other industrial protocols. And the recent Industry 4.0, that and all will come under this industrial electronic devices, whichever you are using, and that too we are going to use with industrial protocols. Okay, okay. So what is a microcontroller? So microcontroller, as we say, we have many embedded systems involved, such as automobile engine control systems, implantable medical devices, remote controls, office machines, appliances, etc. And microcontrollers again, see what are all the information that is being fed as input, that will be analog input. Again, we need to convert those analog input to digital, and while we need to process the data, and again we need to issue the instructions. Again, we need to convert the digital data into analog, and we can see the output. So we have many inputs and outputs that is set as per the industry standard, and it is an embedded system that is used for many applications. Okay, and this is being a cost-effective solution in small-scale industries, because as like large industries, we cannot we have large machineries that is involved, that has been involved with the complex control systems. Okay, complex control systems. Okay, and so instead we can use simple microcontroller based systems in a small industry, in small industries. But the only drawback here is you'll be having limited computing functions. Okay, though it can perform wide variety of operations, but it has limited computing functions when compared to large machines involved with PAC and PLC, etc. Coming to the mini computers, so mini computer will be having the smallest categories. Some of the following characteristics, such as it is smaller in size than the mainframe computer, and it is less expensive than the supercomputer and the mainframe computer, and it won't be that much powerful. With these type of mini computers can be used in the machine level. Okay, for performing the operation, it is can also be used as a mid-range servers, like in the lower level 0 and level 1, as I showed in the distributed control systems. We can use mini computers in that places. Those mini computers will be giving the information to the mega servers. Okay. So the term mini computer was developed in 1960 itself, because it involves small. This is used to describe the small computers, and you can have transistors and memory technologies with the minimal instructions and less expensive peripherals when compared to the previous unambiguous Chelly model. Okay. So these type of mini computers will be designed for specific roles like process control or accounting. And with this, I'll stop today with the mini computer, and DSP and other things. I'll just go ahead with the next class. I hope you in this particular lecture I have covered about what is mean by industrial automation, and what is the control system that is being involved in the industrial automation systems, and what are the different types that is used in industrial automation systems. This different types of ICS, namely industrial control system, that is being involved. With that, I'll stop today. I'll continue with the other control systems in the next class. Thank you.